Formula One has always been a competition not only among exceptional drivers but also among brilliant engineers. Some teams intentionally employ technical tricks and outright cheating, from deceiving with the car's weight to incredible innovative technologies. They all aim to gain an edge in the races. For instance, we will show you the legendary vacuum cleaner car at the end of this video, which nobody could defeat, leading to its eventual ban. Through the rules, the organizers attempt to level the playing field for the drivers. One ingenious technique we're starting with to demonstrate the level of cunning by some teams is hydraulic brakes. In the early 80s, there was a boom in turbocharged engines, which had a significant advantage over naturally aspirated variants. Engineers found a way to equalize the playing field. They installed special water reservoirs on the car, which they carefully drained after the race's start, significantly reducing the weight of their car throughout most of the race. Then the car would pit, where they would refill the water, and the car underwent a weighing procedure. At the time, there were no restrictions on the water reservoirs for the brake system, so it wasn't considered a rule violation, although it clearly undermined the spirit of the royal races. The streak allowed Nelson Piquet from the Brabham team and Keke Rosberg from the Williams team to secure the first and second places at the 1982 Brazilian Grand Prix, the second race of the season. Nevertheless, when atmospheric cars unexpectedly won again at the following race, the United States Grand Prix, the main representatives of the Renault and Ferrari teams, which had more powerful turbocharged cars, raised a protest. The results of the Brazilian Grand Prix were reviewed and Piquet and Rosberg were disqualified. Alain Prost from the Renault team was declared the winner of that race. The organizers of the United States Grand Prix, however, decided not to change the final results, even though liquid brakes were also used by the McLaren team, with Niki Lauda as the driver who finished in the first place. But believe me, this is just the tip of the iceberg when it comes to other team tricks. Sometimes in Formula One you can encounter technical cunning. The team's mechanics rush into the pit lane, simulating a fake pit stop to make their opponents believe they should also go in and change their tires, thereby losing precious seconds. For example, this happened during the 2015 British Grand Prix, when Mercedes mechanics attempted this technical trick multiple times during the race. At the beginning of the Silverstone race, Williams team drivers were leading, and the Mercedes team tried to induce them into making an early pit stop. As a result, on the 14th lap, the mechanics of the championship-winning team prepared for a pit stop and went out onto the pit lane, showing their readiness to receive the car. However, the Williams team did not fall for this trick, and all their cars stayed out on the track. In the end, Lewis Hamilton from the Mercedes team made his pit stop 5 laps later than his technicians initially indicated, after which he returned to the race in the lead. On one hand, Toto Wolff, the director of Mercedes Motorsport, admitted that it was an attempt at deception to mislead their competitors. On the other hand, from a rules perspective, such actions by the teams can be interpreted as a violation. After all, Article 23.11 of the sporting regulations states, team personnel are allowed on the grid immediately before a race or a practice session to assist with the gridding of the cars and must withdraw at the 1-minute board. In the late 90s, the Mercedes and Ferrari teams were engaged in fierce competition not only on the track but also behind the scenes, in the design offices and FIA corridors. During that period, Ferrari noticed that the engines of the Silver Arrows, as the Mercedes were sometimes called, produced more power at the same RPMs. It was soon revealed that the Arrows used a lightweight yet extremely durable aluminum-beryllium alloy to make their pistons and cylinder walls. This alloy was exotic, challenging to work with, and furthermore contained carcinogenic substances harmful to anyone who came into contact with it. Naturally, the governing body intervened in the process, and from 2001 they imposed a complete ban on the use of exotic materials, including beryllium alloys. This decision led to the Silver Arrows losing approximately 40 to 50 horsepower and encountering engine reliability issues after transitioning to traditional metals. By the second half of the 2000s, Formula One became increasingly obsessed with optimizing every square inch of the car's body to enhance aerodynamic efficiency. This was inevitable, given the monopoly of Bridgestone in the tire supply and the frozen development of engines for the next 10 years. However, this preoccupation with aerodynamics led to cars having more complex and cluttered elements like deflectors, ears, horns, chandeliers, fins, and other shapes which were given nicknames by the fans. Most of these additions didn't provide any speed or safety benefits for the car, but created more significant aerodynamic drag for the cars following behind. Engineers attempted to manipulate airflow behind the car to make it difficult for others to overtake. In response to these developments, the Federation introduced new simplified aerodynamics rules for Formula One in 2009, resulting in an immediate change in the leaderboard. In 1981, when the chief judge of Formula One, Jean-Marie Ballester, was battling ground effects and prohibiting elements like miniskirts, Colin Chapman, the renowned engineer and founder of the Lotus team, introduced an innovative car named the Lotus 88. This car was built based on the concept of twin chassis. The first, primary and rigid chassis, carried the aerodynamic body and was designed to employ ground effects principles. The second suspension, which was softer, connected the wheels to the monocoque and engine, providing the driver with more comfortable control of the car compared to traditional winged cars. The Lotus 88 car appeared on the Long Beach track, but during Saturday's practice it was given the black flag, indicating a ban on participating in the race. Despite protests from the team and claims that the car complied with the rules, it was never allowed to start in any Grand Prix. This case serves as an example of how innovative ideas in the world of Formula One can clash with the strict FIA rules and regulations, even without the opportunity for testing. Racing cars in Formula One and other races usually have four wheels according to historical traditions and FIA rules. There have been attempts in the past to use cars with more than four wheels, but they encountered various obstacles. When Patrick DiPaola brought the six-wheeled Tyrrell P34 to the starting grid at the 1976 Spanish Grand Prix designed by Derek Gardner, it was a genuine innovation. The idea was that two front tires were replaced by four smaller 10-inch wheels hidden behind a massive front wing. This allowed for improved mechanical grip and reduced frontal drag, enhancing the car's handling. The six-wheeler found success and the Tyrrell team won several races. Projects with four rear wheels by March and Ferrari did not go beyond testing, and in 1982 the FIA banned the use of more than four wheels in racing cars for various reasons, including safety, standardization, and equality between teams. The F-duct system, like many other innovations in the world of Formula One, was developed to enhance the aerodynamics and performance of the cars. The system first appeared on McLaren's cars in 2010 and was introduced during pre-season testing. The idea behind the system was quite simple. It allowed the manipulation of airflow from the front wing to the rear wing through a special air duct in the monocoque. This would change the angle of attack of the rear wing, subsequently altering the downforce. Drivers could activate this system using a dedicated pedal. However, the F-duct system generated some controversy and raised questions about its legality and safety. Nevertheless, at the time of its introduction into Formula One rules, it was deemed legal, and the McLaren team quickly gained a speed advantage on straight sections of the track thanks to this system. Subsequently, other teams including Sauber, Ferrari, Renault and Force India also implemented the F-duct system into their cars. However, the 2011 season marked the last for this system as the rules were changed, and the F-duct system was banned due to the perceived significant advantage it provided. Active suspension in the world of Formula One represented an innovative technology that allowed a car to adjust its ride height and stiffness in real time to improve its handling characteristics on the track. The system enabled drivers to fine-tune the car in different sections of the track and in varying conditions, giving them a significant advantage. The Lotus team began experimenting with the active suspension in 1987, and Ayrton Senna gave it a positive assessment after testing. He won several races in the Lotus 99T equipped with this technology. However, the real heyday of active suspension came later when Williams developed and introduced the technology in their FW14B car in 1992. Under the control of Nigel Mansell, this car dominated on the track and brought championship titles to the team. Williams truly perfected active suspension. However, in the following season, it became evident that other teams could not compete with Williams without this technology. Along with other changes such as the ban on electronic aids, active suspension was prohibited in 1994. And it's about time to talk about that electronics. The use of electronic driver aids, including traction control, in the world of Formula One was a subject of debate and discussion for many years. Fans were upset that races were turning into a competition of tuned electronics rather than driver skills, as many teams still use stability systems, launch control and ABS. From the early 1980s until 1994, all of these electronic systems were allowed in Formula One, But then the rules changed and these aids were banned. The problem was that it was impossible to determine the presence or absence of these systems in a car, which many teams exploited. In 2001, the FIA acknowledged its inability to effectively regulate the use of electronic systems and reintroduced traction control, starting from the Spanish Grand Prix. However, it wasn't until 2008 that the sport finally got rid of the fan-criticized aids, when the FIA required all teams to use standardized engine control units, reducing the possibility of manipulation with electronic systems on the cars and increasing control over their use. In 1983, turbocharged engines in Formula One became a dominant force despite their initial reliability issues and compressor delays. These engines were introduced by the Renault team and initially demanded a specific driving style. But by 1983, they had become more reliable and powerful, marking the end of an era for naturally aspirated engines. Nelson Piquet, driving a Brabham BMW, became the first champion with the new type of engine in 1983, taking it away from the pioneers at Renault. Under the leadership of Jean-Marie Ballister, the FIA tried to control the increasing power of the turbocharged cars by introducing restrictions on fuel quantity and raising the minimum weight of turbocharged cars. However, by 1988, when the McLaren team led by Alain Prost and Ayrton Senna was dominating, engine manufacturers had learned to extract over 600 horsepower per liter, making their turbocharged engines significantly more powerful than any naturally aspirated ones. Ultimately, the FIA decided to mandate that teams use 3.5-liter naturally aspirated engines to balance power on the track and reduce risks to the drivers. The Brabham BT46B is a famous Formula One car that earned the nickname the vacuum cleaner. This engineering marvel was created by Gordon Murray, one of the most talented engineers in the world of Formula One. The car used a natural fan to generate ground effect, which allowed it to firmly hug the track surface. At the time of its debut in Formula One, it fully complied with the rules of that era and raised no questions, as no one could have imagined that engineers would attach a giant fan to a racing car that created a ground effect supporting airflow from underneath the vehicle. However, the first race in which this car participated, the 1978 Swedish Grand Prix, caused panic among its competitors. Niki Lauda won a straightforward victory. This performance alarmed other teams to the extent that they even threatened to leave the championship if the vacuum cleaner was not banned. Consequently, amendments were made to the rules prohibiting the use of fans to create ground effect in Formula One. No matter how much engineers may want to continually perfect racing cars, it's essential to understand that there's a limit, as losing the essence of these royal races would be a great loss. Thank you for watching.